when we run into chain rule problems, yeah, those other rules still exist. And so the chain rule could be utilized with other rules, product rule, quotient rule. I guess we've used already the chain rule with the power rule, but you know what I mean. When we throw in a product rule, a quotient rule, that's obviously going to complicate things. So let's do a couple examples here of that. So y equals 3x minus 4 over the square root of 4x minus 7. And what we might note here is, obviously we have quotient rule, right? Got a quotient. The chain rule comes in because if I think about that denominator there, square root of 4x minus 7, isn't that 4x minus 7 to the 1/2 power? Yeah. That's where that chain rule is going to come. So I've got a quotient rule, obviously, but I'm also going to have chain rule because this denominator here has an inside and outside part. And so we're going to get chain rule involved too. All right, so we'll start though with the quotient rule. Remember what it is. Low, start with the low. Low d high minus high d low over low squared. Right? And we can either one for the low because we're not doing the derivative of it just yet. So however you choose to write the low. Let's do 4x. Let's do it this way. Low, as is, times the derivative of the high. Well, the derivative of the high, 3x minus 4, the derivative of it's just 3, right? The derivative of the high is 3. Minus high, so 3x minus 4, times the derivative of low. And that's where, to do the derivative of low, we better think 4x minus 7 to the 1/2 power. The derivative of low here has an inside and outside part. The inside's the 4x minus 7, the outside's the 1/2 power. And so I'm going to have to do the derivative of the outside times the derivative of the inside. So the derivative of the outside is 1/2. Inside stays the same, so it's 4x minus 7. The new power, since the old power is a half, the new power would be 1/2 minus 1, which is negative 1/2. Right? Then I multiply that by, get long here, the derivative of the inside. Well, the good news, the derivative of the inside is just what? 4? The derivative of the inside is 4. And then that's all over low squared. Let's go back to the square root of 4x minus 7. Because I think you can see what happens when I square that. With me there? Okay. Well, there's actually quite a bit we could do to simplify this, but let's see a few things, maybe. One way, we could say right here, you got 1/2 times 4. You cancel that 2 into that 4, so that leaves a 2 there. And then, like I said, in the denominator, we got the square root squared, so isn't that going to cancel out? So the bottom's just going to be 4x minus 7. All right, so let's write it 3 times the square root of 4x minus 7 minus, now you can't multiply because it has a minus 1/2. We can't multiply the 2 in here, but we can multiply the 2 here and here. We can distribute that 2 in there, so that'll be better, I think. 6x minus 8 times this 4x minus 7 to the minus 1/2, then divide that by 4x minus 7. Okay? So at this point, if you get that, I'm good, okay? Let me just show you here real quick how we can simplify it a little more, if we want to. That's a good answer, but let me just show you this. It's really kind of neat. All right, so let's rewrite this way. That's minus 1/2, so that flips over. It doesn't flip to the bottom, but it flips over onto this, under this. said, if you don't do this, you're all right, but let me just show you. If I multiply now, if I multiply, so I've got this square root of 4x minus 7. If I multiply top and bottom by the square root of 4x minus 7, so I'm multiplying the top and bottom by the same thing. Well, you see here, if I do that times that, those square roots cancel, so I get 3 times 4x minus 7. And then this times this, right? Okay, see what I did? This times this gives me 3 times just the 4x minus 7 without the square root, because the square roots kind of cancel each other out. Here, the square roots actually cancel out. So the 4x minus 7 square root's gone away completely. So it's just minus 6x minus 8. And then the bottom, since that's to the 1, that's to the 1/2, this is, except if you don't do all this, I'm okay, but that's 1 and plus a half power, so that's 3/2 power, or 1.5 power. And then you could clean that up, that's 12x minus 21. It simplifies down pretty nicely is what I'm saying. But if you don't do all that, I'm still, what do you get? That's 12x minus 21 minus 6x plus 8, so you get, what, 6x minus 13 over, it looks a whole lot nicer, but if you don't get through all that, that'll be all right. Just wanted to show you. All right, let's do a couple more though. Any questions about that? Probably are, but. Okay, so this one, y equals 2x plus 3 cubed times 3x squared minus 9 to the 6th power. 2x plus 3 cubed times 3x squared minus 9 to the 6th power. What do you see there? Chain rule. Matter of fact, 2 chain rules, don't it? Because you got an inside and outside here, you got an inside and outside there. So 2 chain rules. And what else? Product rule? Yeah. So let's start with the product rule. Okay, so derivative here is, so in the product rule, remember what it is, you kind of alternate doing the derivative. So if I do the derivative of the first one here, well, that's inside, outside, chain rule. So the derivative of that's going to be bring down the power, so it'll be 3, inside stays the same, 2x plus 3, new power is 1 less squared. Right? Then I multiply that by the derivative of the inside, which is the derivative of the inside here, 2x plus 3, derivative 2. So all of this is the derivative of that one. If I do the derivative of that one, then this one stays the same. So it's still 3x squared minus 9 to the 6th. And then by product rule, I reverse that. So I keep the 2x plus 3 cubed on this one the same. Do the derivative of that guy. Well, that's again inside, outside. 3x squared minus 9 is inside. 6 power is the outside, so derivative of the outside first. Bring down the power. Inside stays the same. The new power, 1 less, is the 5th power. But I'm not done, because now that's the derivative of the outside, so I have to do the derivative of the inside. The derivative of the inside is 6x. Because the minus 9 derivative is 0. Okay? All right, so let's clean this one up. That'll be 6 times, parentheses, 2x plus 3 squared times 3x squared minus 9 to the 6. See what I did there? like I said, if they have these numbers, lone numbers like that, they usually multiply them together. So that's the first one. Then the second one over here, well, we got 6 times 6x, so that's 36x. And then 2x plus 3 cubed times 3x squared minus 9 to the fifth. All right. Now, here's how we're going to clean this one up, besides that. You notice here, these two parts have a lot of common factors. So let's factor this up, because we can do better than that. So this is what I want you to do on this one. Yeah, you'll notice the common factor, I've got 6 and 36. So I've got a common factor of 6. So what I'm doing is I'm pulling out the common factors here. What else do I have in common? Well, I got a 2x plus 3 squared, I got a 2x plus 3 cubed. I've got a common factor of 2x plus 3 squared. Both of them have 2x plus 3 squared, so I'm going to pull out that. 2x plus 3 squared. And then both of them have 3x squared minus 9. This one's got it to the 6th, that one has it to the 5th. So there's a common factor of 3x squared minus 9 to the 5th. Those are my common factors. So if I pull this off of each one of those, here's what I got. All right, so I pulled out the 6, so it's gone. 2x plus 3 squared, it's gone. But this, I only pulled out 3x squared minus 9 to the 5th, so that leaves me one of those, doesn't it? So by pulling all this off, for this first part, it just left me 3x squared minus 9 to the first. Now what happens over here? Well, I pulled off a 6, so divide that by 6, you got 6x. I pulled off 2x plus 3 squared, so that's 2x plus 3 cubed, so there's still a 2x plus 3 to the 1 power here. I pulled off 3x squared minus 9 to the 5th, well that's what that is, so that one's pulled out. There you go. And last but not least then, this just cleans up a little bit because, of course, that's to the first, so that's 3x squared minus 9. This, if you distribute, you've got 12x squared plus 18x. So, all told, here's what the derivative is. 6 times 2x plus 3 squared times 3x squared minus 9 to the 5th times, what is it, 15x squared plus 18x minus 9 or some order there of some equivalent. So, yeah. Those can get fun. I got one more. Is that okay? Any question? All right. I think I can get this one right here. All right. G of x equals the cube root of 5 minus sine of 2x. Let's finish off with this one. Okay. Again, I would write that cube root as to the 1/3 power, right? So no problem, we got it. So G prime here is, just get this over just a little more. All right, do the inside and outside thing. So we've got on the inside and the outside, 5 minus sine 2x on the inside, and then I've got on the outside the 1/3 power. Remember the outside first. Bring down that, we've done it several times now. The outside, the 1/3 power. So bring down the power, 1/3. Inside stays the same, 5 minus sine of 2x. New power, 1/3 minus 1, negative 2/3. Multiply that by the derivative of the inside. Well, the derivative of the inside, we got a 5, derivative constant, 0. Then we have a minus sine 2x. Do you notice something about that? Maybe if I helped you out there. There's parentheses assumed there, understood there, around the 2x. What I'm saying is here, on the inside of this one, I've got another thing on the inside. Let's call it the inside of the inside. Guess what? If I have an inside of the inside, I've also got to do the derivative of it. So not only do I have to do this derivative of the sine, but I also have to do the derivative of the inside of the inside. But those are going to be separate, just like this inside and the outside I did separately. I've got to do this one separately from, you see what I'm saying? But the good news is, all right, so I do the derivative of the sine, which is cosine, but it's minus sine, so it'll be minus cosine. But I keep that inside of the inside the same. I just extend it to a third part. So this is technically my derivative of the inside. Now I do the derivative of the inside of the inside. Separately. Which is the derivative of 2x, which is just 2. So essentially what this is, that minus sine 2x, that's a chain rule itself. It has an outside and inside. That's what I'm saying. Does that make sense? Where I got the 2 here. Yeah, I got that minus cosine because I'm doing the derivative of the sine, which is technically what I'm calling the 5, the inside. But I have that inside of the inside, so you have to do that as a separate derivative. Yes? Make sense? A little bit? Cleanup wise, let's see. I got a -1 and a 2 and a 1. Let's make that a -2/3. 5 minus sine of 2x. A -2/3 times just cosine of 2x.